Next, let's look at how to identify even and odd functions from its equation. So we have 4 examples here, okay? So let's do one by one. A function f of x defines as x squared minus 5. Okay, so how to determine whether it's an even or odd function? By its definition. Okay, we know if function is even and then f of x equals f of x, right? If it's an odd function, replace x by negative x and then equals negative of f of x. So we first have to evaluate f of negative x. Okay, so we replace x by negative x, see what kind of function we have after simplify. Replace x by negative x, so that's negative x squared minus 5, right? So negative x raised to the even exponents, negative sign goes away, right? Eliminate it, so that's equals x squared minus 5. And then you compare with original function, so we have f of negative x equals f of x, right? That's exactly matching, right? The even function's definition. So the function is even, which is also means the graph must be symmetric with respect to the y-axis. Okay, I just write a short, you know what I mean? The graph must be symmetric with respect to the y-axis. Okay, that's the A part. Let's look at the B. B, we have g of x equals x cubed minus 1. So now we need to evaluate f of g of negative x. Okay, replace x by its negative. Okay, and then simplify. So negative x raised to the third power is like negative x multiply itself 3 times, right? So still have a negative sign outside and then x to the third power and then minus 1. Okay, if we factor negative 1 out, that equals negative of x third plus 1 in the parentheses. Is that right? So is this the same as f of x, g of x? Negative, is that equals negative of g of x? That's the question mark. Okay, this is a negative sign outside, right? Based on definition, it should be equals negative of the function. Is it negative of g of x? It is not, right? Here is a minus sign, here is a plus sign, so it's not equals negative of g of x. Therefore, the graph is not even, right? Even should be equals original function, and then not odd either, right? So this is not equals negative of gx, and it's not equals g of x either. Both not equals, so not even nor odd, that's why it goes to neither. Okay, g of x is not an even function. It's not an odd function either. So that's why it goes to neither. Let's look at the C, h of x. h of x equals 5x to the third power minus x. So we want to evaluate h of negative x. Okay, h of negative x, replace x by negative x to the third power, replace x by negative x, right? And then we simplify. That's negative 5x to the third, right? Negative x to the third power, negative sign going outside. And then minus negative x become a plus x, right? If we factor negative sign out, we have 5x third power minus x. Is this the same as h of x? It is, right? So that equals negative of h of x. So this is what kind of function? That's an odd function, right? So since it's an odd function, the graph must be symmetric with respect to the origin, isn't it? All right, now let's look at the D. The capital f of x equals absolute value of x. So now we need to evaluate f of negative x. So replace x by negative x and then find absolute value. Negative x find absolute value should just equals x absolute value, right? That's the same. Negative sign is eliminated. So absolute value of x, that's the same as f of x, right? So f of negative x equals f of x, that's satisfying even function's definition, right? So this is an even function, and a graph should be symmetric with respect to the what? Should be symmetric with respect to y-axis, right? Okay, so those the symmetric with respect to the y-axis. This one's symmetric with respect to the origin. The A symmetric with respect to the y-axis. Only the B is neither, not even nor odd. I hope you did all those right. That's the solution.